James Webb Telescope detects a structure that should not exist. If we were to find evidence illustrating human ambition toward the universe, it would undoubtedly be the James Webb Space Telescope. Launched on an Ariane 5 rocket from French Guiana, Webb's debut is expected to mark a new beginning for a mission that aims to reshape our perspective of the cosmos. From the outset of its journey, Webb has a long list of discoveries that scientists hope to achieve by utilizing the anticipated observational time through the astronomical lens. Its most touted scientific mission is to observe regions of space over 13.5 billion years ago to detect the infrared light emitted from the first galaxies. Little known to many, this space telescope also has an additional crucial mission: observing exoplanets and searching for the faint glow of civilization or new life beyond the universe. For this mission, the Webb telescope will pay special attention to exoplanets within the Goldilocks zone, also known as the habitable zone of their stars. Scientists hope it can confirm whether these distant worlds might harbor liquid water to support life. Webb will answer a question that humanity has pondered for thousands of years. Are we truly alone in this vast universe? In astronomy and astrobiology, the Goldilocks zone or habitable zone refers to the region around a star where planets within it have atmospheric pressure sufficient to allow for liquid water on the surface and the potential for life to thrive. The Goldilocks zone is commonly discussed in two contexts: within a planetary system and within a galaxy. Planets and natural satellites within these zones are potential candidates for the development and existence of life similar to ours. The concept generally excludes natural satellites due to insufficient evidence and theoretical considerations regarding which types of moons could be habitable when considering the planet they orbit. In our solar system, Earth and Mars, despite not differing much in size, have vastly different climate histories. According to scientists, the distance from Earth to the Sun is just right, neither too hot like Venus nor too cold like Mars. In other words, this fortuitous distance has created favorable conditions for the development of life. This is the most basic criterion that scientists use to classify potentially habitable exoplanets among the millions of shining stars in the sky. Coincidentally, Proxima Centauri b tops the list of Webb's observations from the moment it entered its operational orbit about 6 months ago. Scientists suspect that this place may have sown the seeds for another civilization beyond humanity. Proxima Centauri is a red dwarf star with a mass of about 12.5% of the Sun's mass. This star cannot be seen with the naked eye, yet it is one of the most noteworthy stars in the sky. This is because it is part of the Alpha Centauri system, the closest star system to our Sun. Alpha Centauri consists of 3 known stars, including Proxima. Among the 3, Proxima is the closest, approximately 4.2 light-years away from us. Alpha Centauri appears as the 3rd brightest star in Earth's sky. However, Proxima is too faint to be seen with the naked eye. It is a small, dim star with low mass and has its own planetary system. 2 confirmed planets orbit it, and there may be a 3rd planet. Proxima is a red dwarf star, and like other red dwarfs, it is known to have enormous solar flares. In the Earth's sky, Proxima lies in the direction of our Centaurus, the Centaur constellation. It is a southern constellation, most visible from the southern hemisphere of Earth. While it may be glimpsed from very southern latitudes in the northern hemisphere, many stargazers in the north claim they have never seen Alpha Centauri. Proxima is located about 1/5 of a light-year away from Alpha Centauri A and B. Due to its considerable distance from the 2 main stars, some scientists question whether it truly belongs to the star system or not. Typically, when stars are very close to Earth, they appear bright in our sky. For example, consider the star Sirius in the Canis Major constellation. Sirius is the brightest star in the Earth's sky, located just 8.6 light-years away from us. So why is Proxima Centauri, which is only 4.22 light-years away, not brighter? It is extremely faint, with a brightness level peaking at around 11. This is the nature of red dwarf stars, like Proxima. These stars are the most common type in our Milky Way galaxy, but they are too small to shine brightly. Indeed, Proxima only holds about 1/8 of the mass of our Sun. Proxima Centauri, with its faint red color, has a temperature of only 300 Kelvin, 5,100 degrees Fahrenheit or 2,800 degrees Celsius, contrasting with our Sun's temperature of 5,778 K. Therefore, in visible light, Proxima Centauri shines at only 0.0056% of the brightness of our Sun. In 2016, the European Southern Observatory, ESO, announced the discovery of Proxima b, a planet orbiting Proxima Centauri at a distance of about 4.7 million miles, 7.5 million kilometers, with an orbital period of approximately 11.2 Earth days. Its estimated mass is at least 1.3 times that of Earth. Proxima b lies within the habitable zone of its star. However, a 2017 study indicated that this exoplanet does not have an Earth-like atmosphere. In June 2020, scientists announced the discovery of a second planet orbiting the star Proxima c. This second planet is much larger than Earth and has an orbital period of 1,907 days. It orbits at a distance about 1.5 times farther from its star compared to the Earth's distance from the Sun. Then in 2022, the discovery of a third planet candidate orbiting Proxima Centauri was announced. Researchers using the Very Large Telescope, VLT, of the European Southern Observatory revealed that they had found a third planet orbiting Proxima Centauri. Proxima d, with a mass only 1/4 that of Earth, is one of the smallest and lightest exoplanets ever discovered. It orbits the parent star at a distance of about 4 million kilometers, 2.5 million miles, and completes an orbit in just 5 days. Incidentally, any planet around Proxima Centauri would have to contend with the enormous flares emitted by the red dwarf star, which could signal either destruction or survival. Before the discovery of Proxima Centauri b, the documentary television series Alien Worlds presented the hypothesis that a habitable planet could exist in orbit around Proxima Centauri or other red dwarf stars. It would lie within the habitable zone of Proxima Centauri, approximately 0.023-0.054 AU, 3.4-8.1 million kilometers, from the star with an orbital period ranging from 3.6 to 14 days. At this distance, tidal locking to the star may occur. If the assumed orbital eccentricity of this hypothetical planet is low, Proxima Centauri would move very little in the planet's sky, resulting in perpetual day or night on most of its surface. The presence of an atmosphere could help redistribute energy from the starlit side to the far side of the planet. Although orbiting the habitable zone of Proxima Centauri, the climate on this planet would likely differ significantly from Earth. Proxima b might not experience seasons, being too close to its host star and receiving a higher amount of radiation than Earth. However, astronomers do not rule out the possibility of water existing on the planet's surface. It could appear in regions frequently illuminated by the sun or within tropical belt areas. With such potential, Proxima b is undoubtedly the subject of extensive research. Specifically, astronomers are eager to understand what is happening in the planet's atmosphere. The presence of certain gases on the planet could help scientists determine the presence of liquid water or even signs of life below. You'd want to look for molecules that Earth has to support life, such as oxygen, water, carbon dioxide, and perhaps methane, says Alan Boss, an observational astronomer at the Carnegie Science Institution. Those molecules are called biosignatures. Currently, scientists are still determining whether Proxima b is a transiting exoplanet, meaning it moves across the region between Proxima Centauri and Earth. If this is the case, astronomers may calculate how the planet dims Proxima Centauri when it passes in front of the star. This could help determine the planet's radius and density. Additionally, experts can study the types of gases around the planet by observing the star's light filtered through the planet's atmosphere. However, the likelihood of Proxima b being a transiting planet is quite small. Another noteworthy point is that Proxima Centauri is in fact a variable red dwarf star, meaning its brightness can change in unpredictable ways. In April 2021, astronomers reported the discovery of a flare or a burst of radiation from Proxima that was over 100 times more powerful than any flare observed from our Sun. They described the flare as one of the most intense ever seen on a solitary star anywhere in the galaxy. The explosive outbursts from Proxima Centauri could potentially erode the atmospheres of any planets in its habitable zone, but scientists in the documentary series argued that this obstacle might be overcome. Gabor Basri of the University of California, Berkeley argued, "No one has found any showstopper for habitability." For instance, one concern is that charged particle streams from the star's flares could strip away the atmospheres of nearby planets. If a planet has a strong magnetic field, it can deflect particles away from its atmosphere. Even the slow rotation of a tidally locked planet, rotating once for each orbit around its star, could generate a magnetic field as long as part of the planet's interior remains molten. That's why the best way to determine what is inside the atmosphere of Proxima b is to rely on images of the planet, even though it poses challenges. Despite Proxima Centauri being relatively faint, its light can easily overpower the nearby planets, making them difficult to observe from Earth. The only way to capture an image of Proxima b is to somehow separate the light from its host star, isolating it from the reflected light on the planet. This is an extremely challenging task because Proxima b is very close to its parent star. However, with the powerful observation capabilities of the James Webb Space Telescope, the truth will soon be brought to light. Despite both optimistic and pessimistic signs regarding signs of life on the Proxima Centauri b star system, a peculiar signal from this star cluster has left scientists puzzled. In December, a new candidate alien signal emerged, BLC-1. According to The Guardian, this could be a narrowband 980 MHz radio wave observed by the Parkes Observatory in Australia for 30 hours in April and May 2019. However, there is still something missing to confirm this assumption. Douglas Vakoch, president of the Messaging Extraterrestrial Intelligence (METI) program, explained in an interview with SNA about the missing factors before this can be affirmed. Researchers are attempting to confirm if there is an initial signal. The main challenge is hearing the repeating beeps, which they first heard over a year ago, the METI president explained. The message from space. The repeating signal is the alpha and omega. In the quest for signals from extraterrestrial intelligences, discovering an unusual signal is not enough. It must be repeated. If they don't discover the signal in real time, but only months later, it would be challenging to accurately determine which one is the original signal. While it is intriguing to conclude that it is from extraterrestrials, this approach could lead to a legend emerging without actual confirming data. The search for signals from extraterrestrials is a famously conservative process, and scientists cannot claim they have found extraterrestrials until there are independent confirmations. Therefore, the team does not believe in any signal unless it is repeated. For those unfamiliar with the SETI program, it is the search for extraterrestrial intelligence, bringing together a large group of international scientists who have been searching for artificial signals for decades using a network of large telescopes installed worldwide. While SETI operates passively, METI works in the opposite direction, sending signals to extraterrestrial bits of intelligence. Simultaneously, signals are sent to certain star systems with the hope that someone there will hear and respond to them. But even when the Parkes Radio Telescope in New South Wales, Australia, detected BLC-1 multiple times, astronomers, according to Vakoch, would have to find another independent observatory to rule out the possibility that the signals they heard were not sent by a computer on Earth. It's always a challenge. We might catch a signal very similar to the signals we hope to hear from extraterrestrials, but it may ultimately turn out to be a signal from an entirely different mind, from human technology. As an example, let's revisit the case when experts at SETI discovered a very peculiar signal in 1997. This signal successfully passed all checks for extraterrestrial origins, but later, scientists found the actual source, from the SOHO satellite studying the Sun. So, if BLC-1 indeed is a signal from an advanced civilization, we would know that the universe is teeming with extraterrestrial life. If the nearest star system to Earth is the habitat of intelligent beings, we could statistically conclude that life exists everywhere in our galaxy. However, because we have never detected signals from extraterrestrials anywhere in over 60 years, the likelihood of actual extraterrestrial life existing in our nearest star systems is challenging. Apart from the famous WOW signal, recorded in 1977, and still not fully understood, there are other unique signals that have sparked significant interest. For instance, in 2015, there was a signal from near the star HD 164595. This signal was recorded only once by Russia's Ratan 600 radio telescope, but for over a year, it was investigated as a potential extraterrestrial signal. No repetition of this signal was found at the initial frequency or elsewhere in the electromagnetic spectrum. According to Science Alert, in the quest for new civilizations, humans cannot grasp how extraterrestrials communicate and the origin of signals in the universe. With any reasonable technological discovery lacking a relevant natural explanation, extraterrestrials become the closest and plausible answer. As of now, no data related to the BLC-1 signal has been publicly disclosed. Even if it were revealed, it's highly likely that no one could provide an answer to the origin of this signal. Once again, the question of extraterrestrial signs remains unanswered. On July 20th, scientist Rohan Naidu from the Harvard-Smithsonian Center for Astrophysics in the U.S. announced that the James Webb Space Telescope may have discovered a galaxy that existed 13.5 billion years ago. Naidu stated that the galaxy Glass Z13 dates back to 300 million years after the Big Bang, about 100 million years earlier than any previously identified. He suggested that this could be the observation of stars at the farthest distance that no one has ever seen. Although the galaxy Glass Z13 existed in the earliest epoch of the universe, its exact age remains undetermined, as it could have formed at any time within the first 300 million years of the universe. The unexpected encounter between Rohan Naidu and Glass Z13 occurred one evening after he returned home from a date with his girlfriend. At that moment, his computer reported something unusual. He had developed a special algorithm capable of examining the first images released by NASA. Using mathematical formulas, the program searched for the oldest light in the data from the Hubble Space Telescope. Images capturing the universe always reveal light that has traversed space to reach us. The light had traveled to us for 6 billion years, showing traces of a world as it was 6 billion years ago. The closer an object is to Earth, the younger the light, and the existence and position of the celestial body are closer to the present. The deep field images not only show celestial objects, but also provide a glimpse into the past. The oldest objects or light rays in this image appear red, while younger and closer objects are orange, followed by yellow spots, and finally, blue or white. Naidu's algorithm searches for red spots, particularly the oldest light rays. On an historic evening in July 2022, the program reported the discovery of a galaxy called Glass Z13, causing a sensation in the scientific community. Before James Webb soared into the sky and became the most powerful space telescope of all time, humans were accustomed to the vague data provided by Hubble. With its limited observational range, Hubble offered the most basic data on ancient galaxies. However, it was still not enough, not comprehensive. That's why James Webb becomes the next generation. Glass Z13 was discovered in the early release data from James Webb's primary infrared camera known as NIRCam. However, the revelation about this distant galaxy was not disclosed in the first images released by NASA. When transitioning from infrared to visible spectrum, the galaxy Glass Z13 appears as a red spot with a white center. Glass Z13 spans about 1,600 light-years, while Glass Z11 covers approximately 2,300 light-years. With these sizes, they are considered small galaxies. For comparison, our Milky Way galaxy, a monster in the universe, measures at least 100,000 light-years. What's most intriguing is that since these galaxies are 13.5 billion light-years away, it means the light from them took 13.5 billion years to reach James Webb. Therefore, the images of these galaxies we are seeing are actually snapshots of the past from 13.5 billion years ago. According to the Daily Mail, the authors noted that both galaxies have a mass equivalent to 1 billion suns and formed shortly after the Big Bang, indicating that primitive galaxies rapidly developed and swallowed stars in the region to achieve the shapes we see hundreds of millions of years later. This discovery has dealt a significant blow to our modern theories about the mechanisms of the first star formation, even challenging our understanding of the timing of the Big Bang or the true age of the universe. The mystery of dark matter. The mysteries surrounding dark matter and the cosmic dawn heavily rely on peculiar theories in physics. However, some researchers view this as a challenge because this field of astrophysics involves dark matter or dark energy, things we know very little about. The interactions and feedback between starlight, gas, and dust remain poorly understood. Despite various theories, they lack robust support from existing knowledge. The James Webb Space Telescope has provided new insights, challenging our previous assumptions about the Big Bang and the beginning of the universe. Some researchers today believe that the Big Bang might not have existed at all or occurred at a different time than previously assumed. Alternatively, the processes of universe formation might have unfolded entirely differently from what we imagined and calculated until now. Moreover, the discovery of the Schrödinger's galaxy, SEER 1749, further complicates our understanding of the early universe. This galaxy is one of the oldest and doesn't align with previous assumptions about the Big Bang. It exists in a direct cosmic environment where surrounding celestial bodies have ages inconsistent with SEER 1749's age. The galaxy has persisted for 200 million years after the Big Bang and seems to originate from a different time frame. Errors in determining the redshift of light could be a factor leading to the mysterious appearance of the Schrödinger's galaxy. This galaxy got its nickname from Schrödinger's quantum experiment with a cat, raising suspicions about the accuracy of previous measurement methods. Currently, measurement methods are being tested worldwide, but so far, it seems that these methods are accurate. Meanwhile, even older galaxies have emerged. Redshift is the shift of spectral lines towards longer wavelengths as an object moves farther away. In astronomy, the redshift is represented by the dimensionless quantity z. Z equals 0, which corresponds to the present. If the values of objects in deep space increase, their distance and their look-back time also increase. Hubble has been able to find a single galaxy with a redshift of 6. This redshift tells us that this galaxy is 13 billion years old. The Big Bang is believed to have occurred about 13.8 billion years ago. For a long time, this galaxy, discovered by Hubble, was considered the oldest galaxy. Now, the Webb telescope has brought to light dozens of other galaxies, even older. The oldest galaxies discovered during this time have remarkable Z values. Long-term observations with the Atacama Large Millimeter Array (ALMA) telescope in Chile may confirm Webb's data. Astronomers are doing their utmost to fit Webb's observations into various models of the universe. Only time will tell whether they succeed or not. Discoveries are still too recent to draw definite conclusions. It all began with a mistake. The first image of its kind was actually a result of confusion. American astronomer Robert Williams, that year, had a Hubble team that he could use for both personal and professional purposes. Williams decided to point the telescope at a relatively empty spot in the constellation Ursa Major. Hubble's observation time was scarce, expensive, and in high demand. Researchers worldwide shook their heads at Hal. Williams led a mission to study an almost empty space in the universe using the best and most expensive telescope in the world. Hubble took pictures for several consecutive days. Experts predicted that this observation would at most reveal a few faint galaxies, and Williams risked losing his job due to his unreasonable demands. But then, something miraculous happened. Due to the lack of stars and galaxies shining in the foreground, light from much older stars and galaxies slipped into the image. The Hubble Deep Field revealed that the seemingly empty region was filled with thousands of galaxies with ages up to 13 billion years. For the first time, researchers looked far into space, and an entirely new way of observing the universe was born. That's when researchers came up with the idea of creating a new space telescope. With the new space telescope, they wanted to look deeper into space and reverse time further. Now, the 30-year story has ended, and we are just beginning the James Webb mission. So it will still be very exciting, and we can be curious about the secrets that the telescope will reveal about the edge of space, the most ancient region of space. One thing is certain: James Webb peers deeper into the universe than any telescope before it. Thanks to its 6.5-foot mirror with honeycomb segments, James Webb can capture light that has traveled to us for over 1 billion years. The 21.3-foot telescope is equipped with state-of-the-art technology. According to NASA, the infrared sensors of the telescope are so sensitive to infrared light that they can even detect the gentle warmth of a bumblebee at a distance to the moon. As a result, this telescope will overshadow anything technically achievable. James Webb is believed to be 100 times more sensitive and powerful than the Hubble Space Telescope. The mission's motto might be sharper, deeper, wider, and in doing so, this technology delivers significantly improved color images compared to Hubble. James Webb is not just a telescope, but also an enormous time machine. Our universe is estimated to be about 13.8 billion years old, and Webb can safely capture light that has traveled to us for 13.5 billion years. So this giant gazes at the edge of time. While Hubble revolutionized space exploration, the old telescope couldn't peer as deeply, and the images it could provide of the oldest galaxies were relatively faint and blurry. Unlike Hubble, the new telescope is also placed much deeper into space. Hubble, up until now, is located about 340 miles away. In contrast, James Webb is millions of miles away from Earth. In space, that distance is 4 times the moon's distance. For NASA and all the countries involved in building the telescope, this poses a significant risk. Hubble had to be repaired and upgraded 5 times throughout its years of operation. To do this, NASA's space shuttle missions practically flew to the doorstep of our universe and fixed it. James Webb is too far away to carry out a repair mission. It could be a challenge for the development of space travel in the modern era. NASA has long discontinued the Space Shuttle program due to technical flaws. The only spacecraft currently taking humans into space is SpaceX's Space Shuttle, led by Elon Musk. Of course, if SpaceX follows its plan to send humans to Mars, starting in the 2020s, they might pass by James Webb and replace a few light bulbs. Now let's explore what James Webb has shocked the scientific world with. The oldest objects. Right from the first image NASA introduced to the public, some unusual things were noticed. The Deep Field picture, displaying the oldest galaxies known in the universe in red, stirred up the scientific community. Initial investigations revealed that the oldest galaxies seem to be much older than previously assumed. It appears that giant, luminous galaxies have existed 200 million years after the Big Bang. Currently, international groups of experts are verifying the authenticity of these discoveries and examining whether there could be errors in determining the distances and ages of galaxies from before. If the accuracy of the measurement method is confirmed, all theories about the Big Bang may need to be rewritten. Researchers may soon have to find new explanations for the universe's origin and age. Among the oldest galaxies discovered so far are Galaxy Glass Z13, with an age of 13.5 billion years, and Galaxy Sears 933Y6, which might even be a bit older. It's worth noting that the Big Bang occurred about 13.7 billion years ago, and afterward nothing significant was believed to happen for a long time. However, Webb's images reveal something different. Could there be extraterrestrial life? Alien life. The question of whether extraterrestrial life exists or not has been a topic of interest for a long time. Recently, NASA announced a new discovery. We all know that one of the main missions of astronomical telescopes is to detect exoplanets. The James Webb Space Telescope can detect small planets at incredible distances as they pass in front of their stars. It can also analyze changes in the starlight spectrum to determine the presence of planets. Additionally, the telescope is equipped with instruments that allow it to perform the most accurate measurements in the vicinity of exoplanets. This means that determining the components of planets and any atmospheres can be examined in more detail. The first planet analyzed in this way is LHS 475b, an Earth-sized rocky exoplanet orbiting a red dwarf star about 41 light-years away in the Octans constellation. This is the discovery of a team of astronomers led by Kevin Stevenson and doctoral student Jacob Lustig Jaeger at Johns Hopkins University. They observed and tracked the star's brightness decreasing twice as the exoplanet moved in front of its host star. According to observations, LHS 475b completes one orbit around its red dwarf star, its host star, in just 2 Earth days. Due to the star's temperature being only half that of the Sun, this planet likely maintains its atmosphere despite its proximity to the host star. By analyzing the spectra, scientists are currently trying to determine what is in the atmosphere of the planet. James Webb has demonstrated that it can easily detect various types of molecules. However, the data collected so far has not been fully analyzed to conclusively confirm whether LHS 475b has an atmosphere and could provide conditions for life. The research team also noted that while it is possible that this planet has no atmosphere, there are still some atmospheric components that have not been ruled out, such as pure carbon dioxide atmospheres. The researchers need more accurate measurements to differentiate between a pure carbon dioxide atmosphere and no atmosphere at all. Additional spectra are expected to be obtained with upcoming observations this summer. Webb also reveals that this planet is several hundred degrees warmer than Earth, so if clouds are detected, it could lead researchers to conclude that this planet is more similar to Venus, with a carbon dioxide atmosphere and frequently covered by thick clouds. However, this first successful measurement is just the beginning, and we can expect more exciting results in the quest to explore the edge of the universe. Excellent successor. In the media, the James Webb Space Telescope is often considered as the replacement for Hubble. However, top NASA experts evaluate the term scientific successor to be more accurate. After all, many research objectives that Webb is currently addressing and will address in the coming years could be achievable thanks to the results provided by Hubble. To complement the revolutionary knowledge that the use of Hubble has shown us, developing a successor device specifically designed for infrared astronomy seems reasonable. This is because the light from the distant and ancient regions of the universe is shifted to the near-infrared region due to the universe's redshift. With unprecedented technical precision, the James Webb Space Telescope allows us to peer through objects and galaxies that emitted light for the first time after the birth of the universe and during the cosmic dawn. Furthermore, this $10 billion instrument looks deeper than ever into the mysterious world of stellar nurseries, analyzing the chemical composition and atmospheres of planets beyond our solar system in unprecedented detail. Looking at the following images illustrate the remarkable strides that space exploration based on astronomical telescopes has achieved in the past. Although the images created by YZ, Spitzer, and Webb depict the same region in the sky, they couldn't be more different in terms of quality and detail. While YZ images show nothing more than a blurry set of bright points, at least we can discern individual structures in the Spitzer images. Finally, what Webb captures for us reveals the sky in its true luminous glory. In much sharper images, we observe countless sparkling shapes and complex cloud structures that were indiscernible in previous images. Search for truth among the stars. Taking a closer look at the Carina Nebula, astronomers have unveiled the dawn of a new era in a recent study. Located in the Keel constellation of the Ship and about 9,000 light-years away from us, the colossal structure stretches up to 300 light-years and represents one of the most important star nurseries in the Milky Way. However, the comparison between Hubble and Webb images reveals many sparkling secrets hidden behind the dense clouds of dust and gas. In fact, many objects captured by Webb in the infrared region were entirely invisible in previous images. Speaking of the cosmic star nurseries, perhaps most noteworthy is the stunning image that Webb created from a pre-star in the dark cloud L1527 to understand how stars are formed. Essentially, stars are born when a cloud of dust and gas collapses under the gravitational force. As a result, the material at the center is compressed to the point where hydrogen molecules break down into two atoms. The pre-star formed in this process emitted light, but still had a mass too small to sustain nuclear fusion reactions. This becomes impossible until the baby star accumulates enough additional material and becomes sufficiently dense. This development is currently underway in the pre-star, which is about 100,000 years old. Specifically, this can be seen as a bright point peacefully sleeping at the center of a structure resembling an hourglass made of gas and dust. The star's womb, visible in infrared light, where particles and gas escape from the pre-star and collide with the surrounding material. Similar to human infants, exceptional newborns occasionally burp, appearing as bubble-like objects at the top of the hourglass. They result from collisions of hot hydrogen gas. Webb also reveals that molecular hydrogen fibers have been shocked as the pre-star expels material. These shocks and turbulence hinder the formation of new stars, preventing them from forming throughout the cloud. As a result, the pre-star dominates in space, claiming the majority of the material for itself. Despite the chaos caused by L1527, it is only about 100,000 years old, a relatively young entity. With its age and brightness in far infrared light observed by missions like the Infrared Astronomy Satellite, L1527 is considered a Class 0 protostar, the earliest stage of star formation. Protostars like this one are still shrouded in dark clouds of dust and gas, with a long journey ahead before they become official stars. L1527 has not yet generated energy through nuclear fusion of hydrogen nuclei, a crucial characteristic of stars. Its shape, primarily spherical, is unstable, resembling a small, hot, and puffed-up mass, around 20 to 40% of the mass of our Sun. As the protostar continues to accumulate mass, its core gradually compresses and approaches the stable nuclear fusion reaction. The scene depicted in this image shows L1527 doing just that. The dense dust and gas clouds surrounding it, formed from compacted material, are drawn toward the center, where the protostar resides. As material falls in, it spirals around the center, creating a dense material disk called an accretion disk, supplying material to the protostar. As it gains more mass and compresses further, its core temperature will rise, eventually reaching the threshold for initiating nuclear fusion reactions. With high density, it's not surprising that much of this material will coalesce, marking the beginning of planet formation. Ultimately, this view of L527 provides us a glimpse of how the Sun and our solar system may have looked in their infancy. In the future, as Webb operates actively and more extensively across the sky, we can look forward to many new discoveries from this marvel of human engineering. Humans will continue to wander among the stars in search of a satisfactory answer to the singular question within their universe. On the never-ending journey to explore the past of the cosmos, who knows, we might just uncover the past of our very selves.